Consider a cereal company that is implementing a promotion campaign in which a certain percentage of the cereal boxes they produce come fitted with a shiny cash prize. This proportion, which we'll call P, the company claims is 20% of all boxes, or 0.2. Now, you and your friends decide to test your luck by buying 100 of these cereal boxes. However, you only find 10 cash prizes out of these boxes, so the proportion you found from your sample, which we'll call P hat, is 10 out of 100 or 0.1. So you ponder, is the company being truthful when they say that 20% of the boxes come with a prize? Is there evidence to show that P is less than 0.2? Well, the issue with asking this question is luck. What if you were just unlucky and chose all the boxes that didn't have cash prizes, and left out the ones that did? Perhaps we can ask, how unlucky is too unlucky? And we can honestly kind of define that. Let's assume the company is telling the truth. If the chance of getting such few prizes is lower than a threshold we'll call alpha, then we can reject the company's claim. So alpha kind of becomes this minimum acceptable probability of getting an outcome this unlikely from the sample. For our sake, let's say that alpha is 1 in 100 or 0.01. So let's make an outline of what we have to work with. Let's start by making a hypothesis. A hypothesis is simply a supposition or theory that we can make. H0 refers to the null hypothesis, or the theory that is being put into question. In this case, we are questioning whether P, the proportion of cereal boxes containing prizes, is 0.2. Our alternate hypothesis is that P is less than 0.2. Alpha, which is called the significance level, we set to be 0.01. Our sample size n was 100, and our sample proportion P hat was 0.1. We can reject the null hypothesis if the probability that P hat is less than or equal to 0.1, given that the null hypothesis is true, is less than alpha or 0.01. We can call x a random variable that is equal to the number of prizes found from a sample of size 100. Then, the probability that P hat is less than or equal to 0.1 is the same as the probability that x is less than or equal to 10. So what we're looking for in the end is whether the probability that x is less than or equal to 10 is less than 0.01. What is the probability that x is less than or equal to 10? Well, for each box we have, there are two possible outcomes. There's a 0.2 probability that there will be a cash prize, and a 0.8 probability that there won't be. We can assume these success rates are equal for all boxes, and that every box is independent from the other. We can see that it follows that x is a binomial distribution, with number of trials being equal to 100 and the success rate being equal to 0.2. The probability that x is equal to an integer k from 0 to 100 is given by 100 choose k times 0.2 to the power of k times 0.8 to the power of 100 minus k. And the probability that x is less than or equal to 10 is the sum of the probabilities of x from 0 to 10. A cool way to visualize this is with the probability distribution of x. We can see that the probability of x being less than or equal to 10 is given by the area under the graph from 0 to 10. And so, if we perform the calculations using the formula we acquired earlier, we find that the probability is roughly 0.0057. This is less than our alpha, which was 0.01. Therefore, since our likelihood of getting 10 prizes or less out of 100 is quote-unquote too unlucky, we can reject the null hypothesis. There is convincing evidence that the proportion of prize-containing boxes is less than 20%, and you probably have a solid lawsuit in your hand. What we performed is known as a hypothesis test. Let's summarize what we did. First, we defined our two hypotheses, the null and the alternate hypotheses. Next, we chose the significance level alpha, which acted as our threshold. Then we analyzed the distribution to find the probability of our sample statistic being as extreme or more extreme than what we found. And finally, we compared the calculated probability value to the significance level. If it was less than alpha, then we would reject the null hypothesis. If it was not, then we do not have enough evidence to reject the null hypothesis. And there you go, that is the premise of a statistical hypothesis test.